All right, so I just wanted to talk a little bit more about the setup, and now I have the box on the left and the robot control software and simulator on the right. So to just say one more time that this is a web-based robot control software where you can actually play with the dummy robot in the simulator here before you actually run your commands on the real robot. It's web-based and uses Socket.io to connect to a server running on the Raspberry Pi, which actually is controlling the Teensy. So, for example, I can go to the simulator here, and I can hit this Go command, which will run the simulator and tell the robot to go to a specific position. I can also use the arrow keys. I can go up on the arrow key to go backwards. I can go down to go that way. I can go negative X, positive X, and I can also use ASDW to control the angles at the end of the wrist. So that's how you can play around with it. You could also choose to grab a joint and go ahead and swivel those joints around manually. You can move the X back and forth also via these inputs here. And also you can pop this out and you can actually, if I go ahead and refresh this to an initial state and click this run simulation, you can see it's going to execute every single one of those commands one at a time. So you can see how your robot is going to move. So that's all happening on the right. Now, at this moment in time, the robot software is not connected. I haven't selected a robot. So if I go ahead and do that, let's go ahead and refresh this nice clean slate. I'm going to go ahead and drop this drop down. Now, I have on the Raspberry Pi, again, running a server that automatically searches and finds the control software. When it did, this robot, because I only have one box right now, registered as robot 1. Each robot has an ID. When I select that, you can see on the right side of the screen, you have some information that popped up. Right now, these are just JSON blobs, but I'm going to make it look better later. But basically, each one of these is all the information. It's the state of each motor, encoder position, whether or not it's homing, whether or not it's ready, what the step position is, what the encoder position is, so on and so forth. You can see that the robot is currently disabled. It's not home and it's not homing, okay? So if I go ahead and click this unlock button, that actually enabled all the stepper motors. So you can actually have a software-based stop and enable. Now that I'm connected to a robot, if I were to say, for example, jog joint 0 here, you can see that I actually sent a command down to the motor, and you could actually hear the motor spinning there, to jog joint 0 on the real thing. If I were to hit this go command, it's actually going to move all 6 joints, which right now I only have 2 set up, to the specific position to get the robot to go into this position on the simulator here. I can home a specific joint, so here's an example where I hit the home on J0. J0 right here is spinning, and here's the limit switch for that. So now it thinks that it's home, and it updated on the UI to reflect that. So that's an example of controlling a specific motor and all the motors as a whole via this robot interface. In addition to that, you could actually say, okay, I want to look and learn a little bit more about the kinematics and what's going on. You can actually toggle off that main grid. You can toggle on the joint grids. You can actually hide the robot, and you can even just see the actual kinematics diagram of the robot itself. So you can do some learning there. You can play around with the different distances between all the joints if you wanted to control a different robot and update the kinematics. It can all be done there. So that's an example of controlling the robot via the robot interface. In addition, let's say you want to debug a specific motor. You can actually go to /motor, and on /motor, you can see this is a specific motor control. So I'm going to go ahead and select robot 1 and then select J0. So now I'm going to go ahead and zero that motor out to pretend that this is 0, and I'm going to go ahead and tell that to go to 20 degrees. So I'm going to tab out of that field. So you can see the UI said 20 degrees, and the motor actually just spun to 20 degrees. I can disable that motor. I can enable that motor. If there's an error, I can reset that error. I can manually zero it out, and I can home that motor. So you have a debugging interface there for the motor itself. But again, what's cool about this is it'll allow you to control multiple robots at the same time via a web-based interface. Everything's wirelessly connected. And it's going to be a really cool addition, I think, to the Anon world. Again, it's all wired. It's not going to be wired the same, except I think I'm going to put a couple extra wires so that each individual motor controller can be enabled via their enable pin in the software as well. And there is a breakout board to take the 24 volts, convert it to 5 volts, so that I can power the Raspberry Pi and the Teensy without plugging it into a computer. So that's a little update on the project. I hope you guys enjoy it, and look forward to keeping you up to date when I get the actual ARM